All right, so I included this picture, something in class we're talking about. I was talking about dirt. We need to appreciate dirt, love dirt. Dirt has a bad name. And some of you guys know we got to call it soil because soil sounds better. Because I was telling everybody, we're talking about how important soil is to our life. Dirt, we need it. We can't waste it. And that's what we've been doing in a lot of ways. So 4.3, talk about some more about the importance of soil, properties, how it works and everything. Hitting this enduring understanding again, interact, state of balance. So we have, the hydrosphere affecting our soil. We have, land with the soil, our atmosphere, all balancing, remember rocks turn to soil, and then that can turn back to rocks over time. So interacting, state of balance, we have, soil in abundance, as the natural systems progress. Now, different kind of soil types, that comes down to basically the three main parts: sand, silt, and clay. S-I-L-T. And we'll get into these. But, the sand is the largest particle size, silt, you say the medium, and the clay is very small. And they have certain characteristics that make them good. You want a mixture of these things. These all have drawbacks and positive attributes. Sand, it really is really good for draining, but it's really bad for nutrients. So good for draining, bad for nutrients. Silt, really good for nutrients. But not so good with draining. Well, it can retain, unlike sand, can retain water a little bit too much. But really, silt is kind of in the middle. Clay is really good for water retention. It really helps keep things from drying out. But really bad for draining. You get waterlogged plants, anaerobic situations happening. Plants can die with too much clay. So let's dive into, I like this flow chart. Let's start up over here. You can see this, this circle going around. It looks like a cycle. Yes, it is. This is a rock cycle. Basically, rocks breaking down and then reforming over time. You got metamorphic rock, volcanic, sedimentary, and the rock cycle, over millions of years through the different types, keep things nice and fresh. And these rocks undergo what we've talked about today or recently, weathering. And that can be physical, like just the wind or water, rubbing against it, like the wind and water, that there might be other particles involved. Breaking down that rock, and also chemical, like acids and bases that chemically break down. Oh, forgot what physical, freezing, thawing cycles. Some things freeze, water expands, can break off little micro chunks of the rock. So freezing, thawing cycles. Freezing, thawing up cycles. And then keep moving to the right. This is all our stuff about our soil, the biosphere, how animals, plants affect the soil. Atmosphere, the water cycle. Wind, hurricanes, all those things that happen. The hydrosphere, the oceans, rivers, lakes, grinding down the rocks and canyons. Time, straight up, it takes time for these to go into effect to make our soil. And what I mentioned at the start, we really have to be aware of conservation, keeping this soil with us so we can use it. Remember, dirt is not bad, soil is not bad. We need it to grow the food we need to build our houses. What if we had to build everything on a rock? Think about it. Man. Soil is really an amazing medium. And I'm sure scientists are very curious looking for soil on other planets. Whatever that stuff is up on Mars, probably no good. Probably throw something in about that. There's some kind of stuff on the moon. But yeah, I'm going to add that for the next video or something. Now, look at different types of soil. So soil. Okay. Move over here, particle size, what we just talked about, porosity. So basically draining. How well can water drain through it? And we have blank, silt, and clay. Clay being the smallest, silt being medium, and remember sand is the biggest. I have a lot of clay in my house, and we're doing some gardening the other day. We had some extra sand around. Decided to throw that into the soil, help out the drainage and the aeration, because roots need air too, oxygen. And as you see right here from the last video, remember our horizons. Give soil enough time, you find these distinct layers, usually going from small particles to big particles. Colors changing, levels of nutrients varying as you go down through the layers. Now, water holding capacity, very important, right? You want to hold some water on the dirt in the soil, but not too much. And this is kind of going from the least holding capacity to the most. So we start out with gravel, these big chunks. Then you get to sand. Then silt. And then finally to our clay. Champion of staying wet and holding on to water. And I might add, those nutrients will also be in clay, especially micronutrients. But really, this is kind of what you want. This is what you get in rivers when they flood, the silt landing on the ground, fertilizing that next round of crops. The ancient Egyptian way, I mentioned before. So soil texture, loamy soil. That is the best kind of soil, and it consists of about 40% sand, 40% silt, and 20% clay. So mostly sand and silt for that aeration, the oxygen. Silt, remember the nutrients, and pretty good for water. And clay, really there to hold on to that water more than anything else. So a lot of the agricultural areas are pretty sandy. In fact, the soil around Jordan is there's sand and also silt there. But if you go near a beach or near a more desert area, you can get more sandy soils, and you might just automatically assume more susceptible to drought. That's because it's so permeable. The water just goes right through. The sand doesn't hold on to the water. You can add clay to to the sand to make it hold on to that water, but then you worry about oxygen depletion. Okay, you do that, plants are going to die, just like they would die with not enough water. They're going to die as well if they have too much water. And let's see, 432. Again, the particle size is going to affect that porosity. We have our Fab 3 sand, silt, clay, and to give you this is all in millimeters, about 2 millimeter to 0.05 millimeters. Silt is in that range of, you go between 0.05 to 0.002, and clay is less than 0.002. So that's the size you're looking at. And then down beneath, percolation, bleaching. Remember, percolation refers to water. Leaching, let me rewrite that for you. Leaching, I think that's better, is really related to nutrients. Let me write it over here so you can see it. Nutrients moving down through the column can be good depending on the root depth, or it can be bad. I mean, it's not going to be close enough to the top where the roots are. All right, so let's put this all together. Looking at clay, and these are major characteristics that we want. Nutrient capacity, clay is good. Infiltration, poor. Remember, it's too particle size are too small. It forms like a barrier. Good water holding capacity. Remember, poor aeration, low oxygen. Workability is poor. It's too hard. Like if you tried to dig it, it's going to be almost like concrete. You have to put a lot of water on it to soften it up, to move it. But as you know, clay pots, right? Make it wet, form your pot. Hard as it gets hard, it stays pretty firm. You need a lot more to actually make clay pots, but that's the basic idea of it. Maybe remember that when you think about the differences. Now, silt, all these are just medium. In between clay and silt in terms of these 5 factors. In sand, nutrient, that's poor. It doesn't hold on to nutrients. Infiltration, good. It's good for draining. Doesn't hold water very good because of that capability to drain so well. Aeration is good. We have a lot of oxygen. Oxygen, that's what we want. And good workability. The sand helps you dig rows, helps humans, we can use our different tools to create the crops that we need to create. Here's going back to, remember, just kind of your broad overhead view again of what soil is. It's not just minerals, it's not just rock. I think most of you correctly identified that when I had the warm-up. So about 45% minerals and rocks, almost half. About 5% organic material. Write that again. Remember, all these numbers vary. It might surprise you, but the soil and rainforest is not very rich because of the high water, washing the nutrients away, and the growth rate, decomposition rate is so fast. And here we got 25% water. You kind of see, especially in the video, these are little drops. And this looks like the sky. So 25% air. Just keep that in mind. So these are some really easy to do techniques for figuring out how to test soil. One is the squeeze test. I'm trying to think of a way for us to do this on campus. You just get it wet and squeeze it, and does it form, can it hold a shape? If it can, that shows you it has a little bit of clay in it, and then that might be good for water retention, somewhat with nutrients, but not too much, not holding its form too much, because remember, you don't want too much clay. Percolation, this is very simple. You can dig a hole and measure how long it takes to drain. Like I said, I have a lot of clay trying to fix my sprinklers. I dug a hole around a sprinkler head, filled with water. It took a few hours for the water to drain out because I have so much clay. So I do that every once in a while, that percolation test. Here is you can see these nice little worms. And this is the worm test. Basically, dig up, I can make that better. You dig up some soil. Do you see worms? Guess what? Having worms is good. You want those worms in there. How many worms per cubic foot do you have? And the last one here, pH test. pH is important. Animals, plants, microorganisms have pH ranges they like to stay in for their enzymes to work best. pH also affects how well the soil can hold nutrients. So acidic soils tend to, their ions grab onto the mineral ions we need, and it kind of washes it away. So a pH around neutral is good. You don't want to get acidic soils. And here's a soil sample. Hope we can accomplish this. There's so few soil on campus, but you basically shove this thing into the ground, 6 to 8 inches. And that gives you a nice little plug of soil. You can see this is the top bit of the soil, and this is the bottom. You can kind of look, kind of divide these up maybe into horizons and see what you have. This little diagram here, you can tell the deeper you go, the less nutrients you have. This is phosphorus in parts per million. At the surface, it shows you this is phosphorus per acre per year. 110. Wow, you got a lot of phosphorus at the surface, but you go down 10 inches, it's really a lot less, right? So maybe have you analyze that graph. Oh, that's good. Here we have different factors that affect soil quality. We have biological, respiration, so bacteria in the soil, anything alive. Nitrogen, so you have legumes, plants that can make nitrogen. How many microbes do you have? Enzymes. These are all important. You need these enzymes in there to help facilitate plant growth. Earthworms, like I said, help to recycle. They help to decompose and aerate soil. The root growth, you can look at the roots, how they're growing, and that can give you an indication of what's going on with the soil. And is there pressure from pathogens, right? Weeds, insects, everything else. Then you're looking at chemical. So how much carbon and nitrogen do you have? Okay, the organic matter, the little pieces. Carbon, pH, this cation exchange capacity, base saturation. We don't get into that too much, but that affects how well nutrients can be utilized. and nutrients. Conductivity, you can test that. That kind of gives you the idea of pH. Heavy metals like lead, cadmium, do we have those in the soil? Sometimes they're there. In LA, in some certain parts, there's a lot of lead in the soil, and it's a real problem. So then, this physical looking at it, what color do you see? Second, there we go. Physical. The color, how stability, the little chunks are. We talked about water filtration. I don't know what bulk density is. Oh, I guess just how dense it is. Yeah. If there's a lot of air in it, it's not as dense. Penetration, something like that. Just density. That bulk kind of threw me off. Penetration resistance, is it permeable? Water holding capacity, like clay, right? Can hold that water. Runoff, erosion, rooting depth. How far down do the plants need to get in order to feel like they get enough water? All right, just I guess one last thing. Thanks for hanging. This is kind of a long video. This is a chart that you use a lot, and it's used to kind of like rank your soil. Remember, you want kind of a something in the middle, a loam, something like this is what you're shooting for. But they get percentage of clay, silt, sand. So say I circle this little node here. What would be the percent sand, silt, and clay? So to do that, you just gotta start at the bottom. I'll kind of look down at 30. So 30 sand, and go up to 40. So I'll kind of go to that node. It's 40 silt. So that looks like 36. And then go over 30 for clay. And that should add up to 100, which it does. Now, and this would be called what? Clay loam. Now, let me circle this one here. Let's figure this out. What's this? Sand. Silt. Clay. So, start sand 70%. 20% silt. And 10% clay. And that's 100%. So what I want you to do is I'm going to circle a couple places, maybe 3 places. And I'm going to have you tell me what the percents are. So this will be A right there. This right here will be B. And this right here will be C. So go ahead and write that on the next slide and then answer those questions. Thanks for hanging with me.